Okay, so in this lesson we're looking at section 3.2 on solving angles by knowing what kind of angles they are, if they're vertical, if they're supplementary, if they're corresponding, if they're alternate interior exterior, same side interior exterior, because that can help us to set up our equations. So in these first few examples, they're really short solving problems. Not all of them will be this short, but to just try to focus you in on what do you need to write. And so they're saying we need to find the value of x for which that will make these lines parallel. For these lines to be parallel, these two angles either have to be equal or supplementary depending on what kind they are. So for me to be able to work this question, I need to figure out what's the name of those two angles. What would that be? Okay. Because this is the top right and top right. Everybody agree? So, if A and B are parallel, then the two angles are corresponding. Angles. So the first thing I want you to do is to write down a little statement that says if those two lines are parallel, then these two angles are corresponding. And correspondings are always what? Equal. Well, instead of putting a period on the end of that, why don't we just add that? Which are equal. Put a period there instead. So once you state what kind of angles they are, is because if these lines are parallel, these angles are going to be equal or they're going to be supplementary, or your two choices, depending on the name of the angles you have. Then you set up the equation. Now, if I had more information on these pictures, I could write a lot more, but I don't. So now that I've stated what I know that these angles will have to be equal if these lines are parallel, so I set my formula equal and I solve for x. Now, I'm not writing reasons right now, am I? I did write a sentence to explain why could I set up this equation, but I'm not writing reasons. So do I have to show that I divided by 3? But if I am writing reasons, I do. And some of you didn't do that on your test. You did the math in your head and didn't put it on paper. And that's okay if I'm not putting both columns. But if I'm putting both columns, you have to show the divided. So the question says find the value of x that makes them parallel, and we've done that because we made the angles equal. So, are these angles equal? What are they? Same side interior. So, if line A and B are parallel, then the two angles are same side interior, or you could say what? What's the other name for that? Huh? Consecutive interior. So same side interior. We'll just abbreviate. It's going to get too long and I can't reach it. Which are, what's the relationship between same side interior? Alright, so they're supplementary. Which means I'm going to set 2x plus 80 equal to 180 for my equation so that I can solve it. So some of them you're going to set them equal because they're equal angles. Some of them you're going to add it up and set it equal to 180 because it's an acute of 2, so it looks like it'd make 180. Now, do I have to show that I subtract 80? Oh, so I can do that in my head and say 100? And if you want to show the subtraction, you can. If you don't want to show it in this particular part, you don't have to, because these are really short, simple two-step questions. Not much to them. So x equals 50, you said. So does everybody kind of get an idea of how to write out the sentence? Because the sentence kind of just varies a little bit, and we changed the name of the angle, right? And we changed which are, we either say equal or they're supplementary. So there's only two parts of that whole sentence that vary. Well, I guess unless I change the names of the lines. I mean, if I talk about D and E, then you might have to change the names of the lines. But as long as I'm saying everything else is the same, you're just changing what kind of angles you have, and you're changing the relationship between the two angles from equal to supplementary back and forth, depending on what you've got. All right, how we feel about this so far? All right, then y'all do this one. So in this one, if line A and B are parallel, then the two angles are alternate and interior angles, which makes them equal. Because don't they both look acute? So then I just say x minus 20 equals 70, and then the answer is x equals 90. So the key here with these questions is, because they've been simplified down a lot, you're only focused on those two, it's real easy to name them, see if they're equal, see if they're supplementary, and write your equation. So in this one, if the A and B are parallel, then my angles are alternate interior, and of course, if you set your equation up, you got 20 again. I need to work on that. It's got too many things that seem similar. All right, well, here is what we're going to look at next. What if our problem gets expanded out a little bit more than that, okay? And they tell you that line A, B, and CD are parallel. They also tell you that line S and line T are parallel. So I've got two sets of parallel lines in here. And then they tell me they want me to talk about angle 3 and angle 11. And they've given me some information about angle 3 and angle 11. So this is very similar to what you were just doing a minute ago, but the picture looks a lot more complicated. So I want you to look for the relationship, which two lines make that relationship. I want you to tell me which transversal cut them, like we did yesterday. And I want you to tell me the name of the two angles, if they're equal or supplementary, like we've been doing today. So I'm adding one more piece to the sentence about the two parallel lines are cut by transversal whatever. So you figure out which two are being the parallel lines and which two are doing the, which line is doing the cutting of the two, name it, and find the answer for X. So I'm going to give you a few minutes to try this. Just adding a little bit extra because I want you to tell me which transversal you were using. Alright, so when you solve this, make sure that you think about the fact that you've got the measure of angle 3 is equal to the measure of angle 11. Did you think to write that down? Because now you have something you can write down. Because, see, I couldn't write that on those first few examples, could I? I didn't have that to write. This is the piece that everybody keeps leaving out of the proofs. You know how to set the equation up, you know how to solve it, but you can't write the statement that tells you you know that. And of course, then again, like I said, if you do the math in your head and you want to subtract the 6 and divide by 4 in your head, more power to you. Use your brain. It's good. But if I'm doing a proof, you can't do that. All right. So, hold on a minute. Let me just glance through here real quick. Same picture. So here's the number 2. You don't need to redraw your picture. It's the same exact picture. I've got another one for you to try to see if you can write the correct sentence, label up what you think the two are. And then when you get this one copied down and get working on it, I'll flip it to number 3 and let you try it on your own also. Okay, so with number 2, if we're looking at angle 1 and angle 8, which two lines are the parallel lines to 1 and 8? All right, so AB and CD are parallel lines cut by the transversal line S. So then the angles are, what kind of angles? Corresponding. No.
Oh, sorry.
Same side exterior, because this one's acute and this one's obtuse up here at 1. So therefore, they have to add up to 180, right?
Right.
So we say 100, well, actually, the measure of angle 1 plus the measure of angle 8 equals 180. So 100 plus 2x plus 10 equals 180. So 2x plus 110 equals 180. 2x equals 70 if you subtract. X is 35. That one works out great because we got a name for it. We know what to do. Well, did I go the wrong way? Well, I mean, I know I went the wrong way, but I know I hit the right button. Oh, well. Okay. What? So I see what you're talking about with 11 and 16 on the next question, because 11's interior and 16's exterior. They're alternating. So alternating means they have to be equal. Do they look equal? But they're not the kind of alternating we're used to, because we're used to an alternating being such that both of them are inside and both of them are outside. And then we've got the corresponding thought where they're both on one side, but they'll be equal. So I've got something weird going on here. Oh well, we'll figure it out. All right, but they still make 180. Why? One's obtuse and one's acute. So I just got to prove it. So let's go through and let's think about what we do know. Isn't the measure of angle 12 plus the measure of angle 11 180? Everybody agree with that? Because they're side by side?
Yeah.
Okay. And isn't the measure of angle 12 and angle 16 equal? Because those are what kind? Corresponding. Okay, so the measure of angle 12 is equal to the measure of angle 16. So the thought here is, yes, I have two parallel lines. Line AB and line CD are parallel, cut by the transversal line T, such that my two angles look supplementary, right? But I can't name them because there's no name for that. So I can just say they look supplementary. And then I set up these two equations because I've got one set that are equal, I've got one set adds up to 180, and they both have this together. And I can take that 12 out and put in the 16 and use substitution. So I can substitute in 16 in place of the 12, because you can take this and take this 12 out and put in the 16 because they're equal. This was like you take out 12 and put in 2x for it. I mean, you can take out a name of an angle and put another name of an angle in it, or you can take out a name of an angle and put in what it represents. So now that I've done that, I can fill in my formula. So just because I choose a pair that doesn't have a relationship, it doesn't mean I can't do it. It just means I have to work around it. I have to try to figure out what do I know the relationship to so that I can substitute in an angle I do know something about. So I took out the angle 12 and put in the 16 because 12 and 16 are the same thing. And now I can solve it. 5y plus 15 equals 180 when I add like terms. 5y equals 165. Is that right if you take 15 away? So y is equal to, don't tell me. 33?
Yep.
Now, I was looking at it kind of carefully, not because I was trying to figure out the answer to the question, because I was looking at this number, and I saw a relationship in that number, so I was trying to think how I could explain this relationship to you so you can kind of see why your answer is what it is sometimes. If you ever notice that a number has the first and the last digit added together makes the middle, you see that? The 1 and the 5 add up to 6 for the middle. That tells you it's divisible by 11. So your answer better be a multiple of 11.
Every time?
Every time. For example, if I have 297, the 2 and the 7 make 9. And not only does it tell me that, but it tells me it's 27 times 11. Every time. So just like there are rules for if it ends in 5 or 0, it's divisible by 5. Or if it's even, it's divisible by 2. If it's divisible by 11, the first and last digit have to add up to the middle. And so I saw that, and I thought, okay, I got to think of a number that's divisible by 11 that 5 times that would make it. So I was busy thinking that pattern when I could have just divided it in my head faster. But I like to see patterns and things and look for patterns, so that jumped out at me. All right, that's the end of our notes. Starting. So